See this boulder sitting at the edge of the cliff? What would happen if this boulder slide down to the cliff and there is a house below it? Yes, there is a greater possibility that the house will be destroyed. And as we all know, the bigger or massive the boulder is, the greater the destruction it gives to the house. And the higher the boulder is from the ground, the greater the amount of impact it will result. That is, the boulder itself has an energy. This energy is what we all know as potential energy. Potential energy is the stored energy of an object at rest. This stored energy is based on the state, arrangement, or position of the object. Alternatively, you can imagine it as an energy that has the potential to do work. When the state, arrangement, or position of the object changes, the stored energy is released. There are different forms of potential energy, and one of it is the gravitational potential energy. Commonly, we use the idea of gravitational potential energy on objects near the Earth's surface. Due to gravity, the constant value of gravitational acceleration is about 9.8 meters per second squared. Now, which of these pictures has the potential energy? Correct! All of this possesses potential energy. Now, think of a ball on the table. The picture number 3. It has the potential energy. Once the ball falls, the ball has the potential to move objects along its way. The gravitational potential energy possessed by objects can be expressed mathematically by means of this equation. But before I show you the formula or the equation, let me reiterate that the gravitational potential energy is affected by first, the mass of the object, second, the distance of the object to the Earth's surface, or known as the height, and lastly, the gravitational acceleration. If we are going to combine these three quantities, we could say that potential energy is equal to m, g, and h, where m is the mass of the object, which in kilogram, g, which is constant acceleration due to gravity in meter per second square, and that is 9.8 meter per second square, and the height, which is in meters. Remember, in 1 joule, it has 1 kilogram meter square per second square. The unit of potential energy is in joule, or has a symbol J, since it is a type of energy. We know that the acceleration due to gravity is constant and is always equal to 9.8 meters per second square near the Earth's surface. Let us try to solve the given problem. For example, if the light bulb shown in figure is elevated at 1.2 meters from the ground and has a mass of 0.25 kilograms, what is the potential energy of the bulb? To answer this problem, we will follow the GESA format. GESA stands for G for the given, E for the equation, S for solution, A for the answers. So how are we going to use the GESA format? Let us first identify the G, the given in the problem. In this problem, the given are the height, which is 1.2 meters from the ground, the mass, which is 0.25 kilograms, and the acceleration due to gravity, which is constant, equal to 9.8 meter per second squared. Next, let us identify what equation to be used, and that is our E. Based on the problem, we are asked to find potential energy. And again, what is the equation for potential energy? The equation for potential energy is PE equals M, G, and H. We will multiply the value of the mass, the gravity, and the height. After we identify the equation, we can now proceed to solution, which is our S. In this part, all you need to do is to substitute all the given values in the equation, and it will look like this. PE, or potential energy, is equal to mgh, where m is 0.25 times 9.8 meter per second squared times 1.2 meters. And for the last part, which is A for the answer, just do the operation needed and write your final answer. And as we multiply these three quantities, the potential energy of the light bulb